So if you're going to add these complex fractions, you need to have a common denominator. So you want to pick something that both these numbers go into. So they both go into 6, and we also need to have that x there. Well, then it's just like any arithmetic. 6x times 1 is 6x, so I take 1 times 5. 3 times 2x is 6x, so I'm multiplying this top by 2x. So I multiply the bottom by 2x. So I get minus 4x. So 5 minus 4x over 6x. It says show your common denominators and factor when possible. So for the second one, you always want to factor everything first so you know what you're going to do for your denominator. So when I put my denominator, this is the other way to do it, just make one big denominator. So I need all of the first, and then I look at the second and make sure that that part is part here. Now I can do my equivalency. So to get from 5x minus times x minus 4 to 5x minus 4, I just multiply by 1. So I'm multiplying the numerator by 1 and the denominator 1, so that just stays 2. To get to here from x minus 4, I had to multiply by 5. So if I multiply the denominator by 5, I got to multiply the numerator by 5. 5 times 7 is 35. So it would be 37 over 5 times x minus 4. And that's not going to ever reduce like that. So if you pick one that is not the same denominator, you follow the same steps. I need the x minus 5, and I need the x minus 7. So now I look, what did I have to go to get here? I had to multiply by x minus 7. So if I multiply the denominator by x minus 7, I multiply the numerator by x minus 7. And to go from here to here, I had to multiply by x minus 5. So I'm going to multiply both by x minus 5. Now it's just trying to simplify. So 2x minus 14 plus 3x minus 15, x minus 5, x minus 7. So that would be 5x minus 29 over that same. And that's not going to factor anymore to reduce. I'll just show you the denominator on that one. So sometimes you have to factor. Usually if there's a factor over here, it's going to be the same as one of the factors. So again, your denominator would be, I need a y plus 10. This one needs a y plus 10 and y plus 2. I already have a y plus 10, so I put my y plus 2. It's the same thing you would do if you were adding 1/3 plus like 3, 6. Say, okay, they both go into 6. 3 times 2 is 6, so 1 times 2 is 2. This one already is 6. 6 times 1 is 6. 3 times 1 is 3. It's the same rule, just has algebra with it. So this is a review. If you saw this here, I'll do a couple even problems. If you forgot your rules, multiplication of the same base, you add the exponents. and then division is subtraction of the exponents. But this is where it comes from. If you ever get stuck, you can always write it out like this, and then you can see what cancels. So 4 goes into 20 5 times, and then I can go cancel out 3 of those a's. So that leaves me with a to the 6th. So you realize that, oh yeah, when I'm doing that, I'm subtracting. All 4 of these b's cancel out, so just a to the 6th over 5. Those are easy, a little bit easier. If you have a fraction and there's a plus or minus, then the only way you can cancel anything out is the factor, and I'll show you why. So I can take an 8 out of that. I can take a 2 out of that. Now that cancels out. 8 divided by 2 is 4. If you wouldn't have done that, if you would try just to cancel stuff out, you'd say, oh, that's 4, that's 4, that's 8, and you end up with the wrong answer. Just like you can't, if you have 7 plus 2 over 18, you can't cancel the 2 and the 18 and get 9 and end up with 8/9. You can't do that because 7 plus 2 over 18 is 9/18 or 1/2. So it doesn't work. You can only cancel out multiplication. So in all these, you just need to factor. If it factors. That one, I wonder if it's a misprint. It doesn't factor. Sometimes you can factor twice. You can take a 4 out of there. And then I just factor above. Usually something will cancel out. In this case, only the 4 doesn't factor as far as you think. Multiplication, I would just draw a line across, and then you can treat it just like 1, 2 up at the top there. You might say, get my numbers together, but you can also just cancel out and say, oh, I have 2 A's right there. I can cancel with those 2 A's. I have b to the 3rd. I can cancel that out with b to the 9th and get b to the 6th. 30 over 20. That cancels out. Just do a little bit of marking it up. The key is when you divide, the only difference is you multiply by the reciprocal. And now you can go cancel stuff out. Those b's cancel out. Just treat it as one big fraction. Down here I have 8 a's. So 2 of them cancel out here, makes that a 1. So I'm going to have a to the 6th. Still have b to the 5th. Now I got that all taken care of. 2 goes into 4. So I have 2 goes into 8. So we end up with 3/4. Same thing here when you're multiplying this out. If you write it in factored form, you'll be able to reduce easier. So this is just like one big fraction. So now the stuff cancels out. You can simplify from there. If it's division, same thing, multiply by the reciprocal. This one right here, you're going to go left to right. So this is going to be flipped. But while you're writing it, you might as well just factor everything. Factors. So anytime you can take something out, it's going to make it easier to see. This one we have to flip, so the 8 times x minus 2 goes down here, and the x plus 1, x plus 7 goes up here, and then you can cancel things out.